Welcome to the ETH Berlin Embark competition. Embark is a super powerful framework for developing decentralized applications on Ethereum, and ETH Berlin is this incredible event that's going to be happening in Berlin from the 7th of September 2018. It's going to be more than 1,000 people gathering from all over the world to build all the best things together. And at Embark, we thought we'd add to the excitement and flavor of the event by encouraging people to build their own decentralized Twitter clients in hopefully 40 minutes or less. So we've created this open source GitHub repository for you, which you can find at github.com/status-im/ETHBerlinEmbark. And it contains a template with everything that you need for your own decentralized Twitter clients, as well as a whole bunch of instructions about what code you need to add where in order to make it all work and produce something which looks like this. So the competition itself is very, very simple. If you can get this running locally, and if you can take a screenshot of your own tweets running on your own decentralized Twitter, and then tweet that with the hashtag Embark, hashtag ETHBerlin, and hashtag Ethereum, we will give you 250 SNT directly through Status at the event itself. So come and find us. We'll be all around, and we'd be more than happy to take you through this and make sure that everybody can build really powerful decentralized applications with increasing amounts of ease. So if you have never heard of Embark before and are wondering what this is all about, you can go into the overview file and take a little read about what the aims of this tutorial are and what Embark is and what it allows you to do. Embark was in fact the first framework that was available on Ethereum and was the brainchild of a man called Yuri Matthias, who was working on it alone and part-time for quite a while, but they've since joined Status, and we have been able to fund an entire development team to work on this. And so the improvements in Embark over the last 6 months have been unbelievable to be a part of. And you'll see that for free, Embark allows you to run a blockchain node, to run an IPFS or Swarm node and connect to those directly with a single line of JavaScript to either upload or fetch files from these new decentralized storage networks. It allows you to connect directly to Whisper. There's ENS name capability coming in 3.2. It compiles Solidity, Viper, and Bamboo smart contracts. So Solidity is the most popular programming language for smart contracts on Ethereum, but Viper is a really cool Python-like alternative that also targets the EVM, and Bamboo is also really an interesting and quite experimental alternative that's quite fun to look into. Embark supports all of those, as well as a really robust testing framework and a really neat terminal dashboard that's I'm going to get to show you in the course of this tutorial. So once you've gone through the overview, got a sense of what it is that we're going to do in this, it's also quite important that we get your environment set up correctly. So you'll need Node version 8.10 or above, because we'll be using some await syntax in this tutorial, which I'll explain when we get there. We also recommend that you use something called NVM, which is the Node version manager, and it makes it really, really easy to manage different versions of Node as you move between different projects that have different requirements and dependencies. It's really a very neat tool that works very well, and we highly recommend it. You'll also need IPFS, which is the appropriately named Interplanetary File System. It's a content-addressed distributed file store that we'll be using for our user pictures in this tutorial, and Embark connects to that automatically for you if you just install it. The instructions are there. You can also install Geth, which is the Go Ethereum clients, version 1.8.11 or higher, and again that comes with some installation instructions. And then you need to have Embark, and if you don't, it's as simple as doing npm install g Embark. You should get version 3.1.7 and potentially version 3.1.10 by the time that this tutorial is out. Either will do. Once you've got all of that set up, it's time to get started with this tutorial. And the first thing that we need to do is clone the repository itself. So we can go ahead and open a terminal. And it's as simple as doing git clone and then pointing it at the ETH Berlin Embark repo. We should be able to clone into it fairly fast, although the internet can be a little bit unreliable here sometimes. Once you've cloned into it, you can change directories, make sure you're in the right place. And then it's also quite important, there are a few different branches in this repository, which you can check out with the command git branch with some verbose and all flags to see everything that's in the repository. And we're most interested in the start here branch. So if you git check out start here, you should see this message that you're set up to track a remote branch that's called start here. We can now sort of take a look at what Embark comes with for free in this template. And most of this should be familiar if you've used any kind of framework for developing on Ethereum before, but one of the really unique things about Embark is just how modular and configurable everything is. So it comes preloaded with this amazing config folder, which we'll go through as we get deeper into the tutorial. But this is where you specify everything from how and which blockchain you connect to how you connect to Whisper, how you connect to IPFS and Swarm, how you set up your local web server. That's where ENS name support is also going to be. So all of these different configuration options which allow you to actually build properly decentralized applications, that are stored on a distributed store and that use smart contracts deployed onto the network of your choice, and that have potentially, in fact, the entire DApp front end stored on IPFS or Swarm, which is also something that you can do directly from Embark. That's really, really quite powerful, and it moves us closer and closer towards actually having a properly integrated development environment for Ethereum, which is something that a lot of people are, really quite keen to see, because it signifies a kind of maturity about the tools that really is important for the long-term sustainability of these kind of networks and technologies. So you'll also have your contracts folder. This is where you write your smart contracts. As I said, you can do this either in Solidity, Viper, or Bamboo. We're going to be writing smart contracts in Solidity because it's the most popular and well-known language at the moment. You have the app folder, which is where you write your front-end JavaScript and maybe some HTML and CSS as well. This template comes preloaded with some instructions for how to add which code where, which we'll be following as we go along. And then also a test folder. And that's where we're going to be writing all of the tests for our smart contracts. I think that it's really important that we begin to shift paradigms about how we write code, particularly for these decentralized networks, and particularly when we're writing contracts that will handle money. That can be a huge honeypot or incentive to malicious actors, and you need to think very, very carefully and test very, very thoroughly everything that you do. To make sure that the contracts that you write actually perform in the ways that you expect them to, and that they're not easily manipulated in any one of a number of different attack patterns that have become obvious as Ethereum has grown over the last 3 years. So we're going to be doing some tests in this tutorial, because test-driven development is it's super important, again, for the kind of sustainability and social trust that is required for these technologies really to function and perhaps even to reach some kind of mass adoption. The first thing that you need to do once you've switched onto the Start Here branch is just make sure that you install the node modules that are defined in your package.json. If you're a web developer or have worked with front ends at all, this should be fairly familiar. We're just going to use the node package manager to pull down all the dependencies that are specified in our package.json and install them so that we can get going with writing some code. Once that's happened, Embark actually will run everything you need to with one single command. That's IPFS, geth, your local web server, your connection to Whisper, everything that you specified in your config folder will start up with one simple command, and that's Embark run. So if we hit that, we'll also get this really cool interactive tutorial, this interactive dashboard, which allows us to see which version of Embark we're running, what version of our blockchain node we're running. It starts up IPFS, it starts our blockchain, it also fires up the web server. It'll compile your contracts for you, and as soon as it's done compiling those contracts, it will deploy them onto the network. If that all goes to plan, it should return an address for that contract, and it should be in green. It'll then give you the outputs of the Webpack process that moves everything from your app folder to the dist folder, which is what's actually served to the local web server, which is running on localhost 8000. And that should look something like this. You should have access to a number of different accounts. If you choose an account that actually has Ether in it, you should be able to see at least the fields for usernames, descriptions, and the button to create a user. Obviously, none of this will work because we need to wire it all up by following the instructions given in this repository. So we've walked through our first run with the interactive Embark dashboard, and now it's time to code our first smart contracts. So the first thing that you need to do before we actually dive into the Solidity code is open the project in a text editor of your choice. I particularly enjoy Visual Studio Code because it comes with a whole bunch of extensions. Material icons is quite nice, just because I'm a visual thinker. But this Solidity extension by Jean Blanco is in fact the reason that I use VS Code. It comes with code coloring, various different highlights and suggestions and completion, and it really does make writing smart contracts quite a bit easier, and it will sort of alert you to various different security vulnerabilities as you go along, and it does again add to the flavor of trying to build in a properly integrated development environment. So we can go ahead and open our ETH Berlin Embark repository. The structure should be fairly familiar from what we've already done and looked at in our terminal. We've got our app folder, the config folder, contracts, which is where the shell for the Twitter exists that we're about to fill in. Dist, which is what gets served to the website once everything in app has been bundled and built. And then this test folder, which includes a JavaScript file that we're going to use to test our smart contract that we're about to write. So I need to assume a little bit of knowledge with Solidity in order to get through this tutorial and the time constraints that we have. But if you're a web developer or JavaScript developer, some of this should seem fairly familiar to you. Solidity is kind of like JavaScript in a way, except that it's strongly typed. There are a number of other really important and big differences, obviously, but if you can write JavaScript, Solidity should at least be approachable for you. The first thing that we're doing is declaring a kind of data structure which is called struct. You can see that we also have mappings, events, we have bytes 32, we have strings, we have uints, we have ints, we have addresses, enums, and a few others. For our purposes here, we need to first be able to store all of the different users of our decentralized Twitter client on the chain. So we create a struct for each user which contains relevant information for that user, like when they were created, what the username is, what the description is, which address owns this user, some string to store the picture because we'll be storing it as an IPFS hash because it's a content addressed store, which means that every single piece of content has a unique hash that it is addressed by. So we can use that hash rather than storing the image itself in the chain, which would obviously be much heavier and more expensive, which is just store the hash. And then an array of strings that represents the tweets from the specific user. We then have a mapping from some bytes 32 value to this user struct, and we declare the name of this mapping to be users. So you can see that the bytes 32 object here is going to be the key, which is a KEKAK 256 hash of the username that is then mapped to this user struct. And you can see that one of the other features of Solidity that's not akin to JavaScript perhaps is that it also comes with these scope modifiers. So if you declare some structure or function, rather, if you declare some structure as public, then there will be an automatic getter function that is written for that. So it means that we can use these two public mappings to fetch users and owners without actually having to write our own get functions for them. There are a number of other different modifiers that you we can use in Solidity from private to internal to pure to view, and a few others that would be more familiar to people perhaps coming from an object-oriented background. And the other important thing to note about this, I suppose, is that if you don't declare a scope modifier for these kind of things, or indeed for the functions that you write, it defaults to public in Solidity. So it's something to be aware of, because that can be a security concern. We also have a mapping, but this time the key is the address that's sort of specified here in the structure, and it maps to some bytes 32 value, which is the hash of the username. And again, this is public, so that we can easily fetch information about users when we need to display it or search for it, as you can see is possible up here. So, we also have an event which is called a new tweet. So events are really useful for storing information off-chain and updating your UI. So these sort of go into the logs with each transaction, and then you can filter through those logs to find the events that you're interested in, and use those events to update UI and inform users of the state of different transactions or the results of them, or various different things. In this case, we're actually using an event to store the tweets. So whenever anybody tweets, we will emit an event and then filter through the logs coming back from the blockchain, find those events, and update our UI with the information coming back from them. So you'll see that this is some bytes 32 hash again, and this represents like the username hash of whoever tweeted, then the actual string that represents their tweet and the time that it was tweeted at. So that's the sort of basic data structure that we'll be using in this contract. We then have various different functions that we'll need to fill in some code for. You've got to be able to create an account, edit accounts, check that a user exists, and actually tweet. So if you look at our create account function, it's only expecting two parameters, some username and some description, which is all we need to create an account. It then goes through a variety of checks before we're expected to add in code. So prior to Solidity 04 to 20, I believe, we didn't have these require and it's just assert words. We used to just sort of write simple conditionals, so we would have changed the logic in this function around and said if the username has no length, then throw, otherwise continue. But the problem with that is that it's very, very difficult to debug that kind of pattern in Solidity. And what's more is that if a function throws, it consumes all of the gas that the user sent along with it. So that's a really poor user experience. So Christian Leitzwein and the team recently introduced these require and assert keywords. And what require will do is that if the function fails at this point, it will stop execution and return the rest of the gas to the user and put a 1 onto the stack, so it becomes quite a lot easier to debug. Assert is a much more stringent condition, and you should only really ever use asserts when you're checking something that should always be true. You know, like assert that A is bigger than B, because assert will throw, and that means that it will consume the rest of the gas sent to that function and put a 0 onto the stack. So it should only happen when something has gone very badly wrong. So require seems to, generally speaking, at least for these simple contracts, pop up a lot more often. Here we're checking that indeed a username has been passed in by making sure that its length is greater than 0. We're then using this TechAct 256 hash, which is the pre-compiling EVM, to generate the username hash based on the username that is passed in. And we're then taking a look to make sure that this user hasn't already been created. And how we do that is we look at this user's mapping, we pass in as a key the username hash which we've just generated, and we make sure that the creation date is not, is equal to 0, right? Because if it weren't equal to 0, then this user would already have been created, and so we can't create them again. So it's important that it is, the creation date there is not yet set. And then we also need to make sure that the owner's mapping here, which has as a key addresses. So if we pass in the address of whoever made this call, it also shouldn't be 0. I.e., it should have come from some address. And this is perhaps the other thing that's quite neat to know about Solidity, is that there are these various global objects available to you, like message.sender, which will return the address of whoever sent you that message, or message.gas, which will return the value of the gas sent to that message, or message.data, which will return the hex encoded data sent along with that message. There's also tx.origin, which is sometimes useful when you're using like chains of proxy calls rather than message.sender. But this is one of the really neat features of Ethereum, and just the way that it is architected, is that it's this object-oriented environment in which you know always which messages have come from which objects. And there's not really another object-oriented environment in the world like that. And so, rather than requiring an address as a parameter, which is really quite easy to manipulate, you can just get access to this globally accessible objects to do with the message itself that has been sent when calling this function. So now that we've checked through all of our initial conditions, if all of these things pass, it'll be time to create a user. So over here, you can come in and just make sure that everything's lined up. And we're using exactly the same pattern. So we look in that user's mapping with the username hash as a key, and then we look into each individual value here, the creation date, the owner, the username, the description. We update them either with now for the creation dates, message.sender again for the address of the owner, and then username and description will be passed in up here as parameters. There's one other thing that we need to do, which is also update the owner's mapping. Make sure that it also reflects this new user and who the owner is of that. So again, we're checking in this owner's mapping with the key that is the address of whoever sent the message, and setting it equal to the username hash that we set up there. One of the other things that I really like about VS Code, by the way, is that it has this integrated terminal, which is just pretty cool. And I'm just going to make sure that it's using the correct version of the node before we continue. So the next thing to do is make sure that our edit account function actually works. And so we can scroll down to our edit account. Again, we've got one simple require statements which ensure that the user exists and that the creator of the user is whoever has sent the message to edit this account. Like, you want to make sure that not any random person could just send a message to edit my account. Only the owner of that account can send a message to edit it, which is what that require statement is checking. If that require statement passes, then again we can go and look at the user's mapping with that key, look at the description now updated with whatever was passed in. We also potentially need to update the picture hash, which is the hash of the picture in IPFS, i.e. the path in IPFS to that picture, because they're equivalent, given that it's a file, distributed file store that's content at rest. And here we are going to use an if statement. So again, we just check that indeed a picture hash has been passed in by making sure that the length is greater than 0, and if indeed it is, then we'll look in the same mapping, except that the picture value this time and set it equal to the picture hash that is passed in. We then need to just have a separate function to make sure that we can check a user exists very easily. We'll be calling this function rather than sending transactions to it, and calling data off the chain is always free. That will become clearer when we write the tests, exactly why we need this function. It just returns some Boolean value, either true or false. And like I was explaining earlier, if the creation date is non-zero, then we know that this user must exist. We don't need to check anything else in that struct. If the creation date is non-zero, then we know that user has indeed been created. The last thing that we need to do is actually tweet. So in order to do that, it's 4 simple lines. We go through one require statement to make sure that indeed some account has sent us this message. That the sender has indeed come from an account, and then we can get the username hash of that sender's account by looking at the owner's mapping with the key of message.sender. We then also get our user based on the username hash that we fetched here. And it's quite important that we fetch this from storage. So this is something else that's obviously very different between JavaScript and Solidity, is these two keywords, storage and memory. When you write something to storage in a smart contract, it costs gas because you're updating the state of that contract. Whereas if you keep something in memory, it means that it's only sort of kept locally for the execution of that function and then forgotten about. So it's not written into storage, it doesn't therefore change state, and often you can make function execution quite a bit cheaper by using memory. It's quite useful, particularly in my experience perhaps with arrays and arrays of strings, whereas when working with structs as we are here, generally storage seems to be the go-to option, though different contracts will obviously have very different requirements. We then also need to fetch the tweet, or we set up a tweet index that we can update our array of strings at. So we create a variable called tweet index. We look in the user's tweets and we just update the length of them by 1. We then use that tweet index as a key to update the tweets array in this user struct with the content that was passed in with this message. And once that is all done, the final thing that we need to do is just emit an event that we specified up here, if you remember, as the username hash that it comes from, the tweets and the time. So down here, we pass in exactly that, the username hash, whatever the content was, and now we use the emit keyword to send it out into the world so that we can filter it in the logs that we're listening to and display it to the user. Once that's all done, if you take a look here and actually save your smart contract, you'll see that Solidity will recompile it automatically for you. And again, this speaks to having an integrated development environment. All of this stuff should just happen in the background and should allow you to really focus on writing good code rather than having to switch back between multiple different tools and go all over the place. As soon as we save our updated smart contract, it gets redeployed, Webpack reruns, everything gets served against the browser, and it should be good to go on the smart contract front. You might think at this stage that it's time to write the front end that interacts with the smart contract we've just written, but there's still one important step before we can get there, and that is tests. So like I say, test-driven development is an incredibly important paradigmatic approach to adopt when writing smart contracts. Obviously in this example with Twitter, because we're not actually storing money in our smart contracts, we can perhaps be a little bit less focused on tests, but we are going to go through how to write tests here because it is an incredibly important skill to have when writing smart contracts that can potentially secure money. Or, personally identifying user information, which does kind of exist in this Twitter contract, and we need to make sure that our contracts behave in exactly the ways that we expect them to, and that our designs and crypto-economic thinking around how we actually craft this code behaves as we model it to. And tests are a great way of making sure that that stuff does work in a reproducible and falsifiable way. So please pay great attention to your tests, because it really is like one of the most important things when writing contracts for these kind of technologies. So if you have a look in your folder structure, you'll see that there's this test folder with a JavaScript file for testing our smart contracts. Again, this comes as a sort of pre-written template for you, so that you can focus on understanding the key parts of these tests. First of all, we get a dTwitter object. This is provided for free by the code generation that happens in the background with Embark when we write smart contracts. It's able just to pull them in with a simple require statement, and then we can specify all of the different methods that we just wrote about: creating an account, editing it, checking that the user exists, those public users and owners mappings, and the tweet itself, by looking at that contract object and checking out its methods. You'll see later that you also get, for instance, the Twitter.events. And so like that nice logical breakdown is just one of the features of coding in Embark. We also set up an accounts object. Then there's a bunch of different config that you can do, you don't do here. because it's not necessary. But again, this speaks to just how extensible and modular Embark really is. So when you start writing more complex sets of advanced contracts that interact with each other in much more intricate ways, you can specify all of that not only in this config folder, but also in each individual test. We then set up some test parameters for usernames, descriptions, and tweet content, which are fairly unimaginative there. And then we get into actually testing the contract. So if you've ever written tests in Mocha or Pi, this kind of stuff should be fairly familiar to you. Basically, what we do is we declare our contracts, and then we do these sort of, they're called describe blocks, and we sort of need to describe what it should do. So in this first test, we're going to send a transaction to create a Twitter user with test handle as the username, description, and that transaction should be successful. Importantly, we're also using asynchronous functions here so that we can access the await keyword, which is why we had that dependency on node 8 or above. And the reason that we use await is that it's just simply much more readable and easier to reason about, and easier for other people to contribute to an open source project than using chain promises with .then. Especially again when you get to more complex and advanced sets of contracts, you can have like 20 different promises chained in one test, and that becomes exceptionally difficult for open source contributors who are not necessarily as familiar with the project as yourself to get involved with. Whereas if you use await, kind of anybody can read what's going on. So the first thing that we are going to test is whether we can indeed create an account. This is going to take one simple transaction. So you can see we set up a constant that we can then test in our assert statement. We use the await keyword, and we call our create account method, which we specified up here, linked to the methods on this Twitter contract object. We pass in the parameters it's expecting, and then we use this .send. There are essentially, as I kind of hinted at a little bit earlier, two different ways of interacting with your smart contracts from JavaScript. You get either .send or .call. .send you use when you're updating states, and that is obviously transactions that you are therefore paying for, because to change state on Ethereum costs gas. So when you use .send, you're spending gas. And when you only want to fetch data from the chain, just leave it off there, then you can use .call, and .call doesn't update the state at all, so it is free. It's quite an important distinction to be aware of. Once we've got this create account transaction that's come back, which is all handled by this await keyword, we can then assert that the status of this is indeed what we're expecting it to be, which is true. Next, we need to make sure that we have indeed created a user test handle. So if that creates transaction has been successful, then checking that this user exists should also be successful. And the way that we're going to do that is by looking into the user's mapping. If you remember, this user's mapping is keyed by the bytes32 value, which is the username hash. And so that's what we need to pass in, not the actual username. And in order to get that hash, we look at the Web3 library, which has this utils object in it, and in that you have the clicker 256 hash function, which we can apply to the username, get what the username hash should be, call that, and make sure that what gets returned is indeed the username and description that we were expecting. We then need to make sure that creating an account has also created a value in that owner's mapping, because that's what we expect from that first function that we wrote. Not only should we create a user, it should also add that entry to our owner's mapping. So let's just check that that has indeed happened. And again, we're using a very similar pattern, except instead of calling the user's mapping this time, we're calling the owners, and the owner's mapping is keyed by accounts. So instead of sort of hashing the username, we just, again, looking at the Web3 RPC, looking at the ETH API there, and default accounts will be read by Embark as the first account in the array of accounts that you're using when running that blockchain node that is shown in your interactive dashboard. For this one again, all we need to do is .call it because we're looking to fetch data from the chain, not update states anyway. Then we need to check that this username hash that comes back from this is indeed the hash of our username as we would cast it in JavaScript. We also need to check that test handle exists by testing our user exists function, which we'll be using in search. So rather than sort of looking in the user's mapping this time, what we're going to do is we're going to call the actual user exists function, and this expects that bytes 32 username hash. So we set that up there, and then call the user exists function. This may seem like we're duplicating work a little bit, but it is useful when writing front-end code, particularly for the search. The last thing that's the second last thing that we need to do is make sure that we can actually edit accounts and that behaves in the way that we're expecting. So again, we set up our username hash in the same way that we just did before, and then we do an updated description by sort of concatenating edits onto that string, and this is the form of an IPFS hash. So we set that up for our updated image hash so that we can ensure that the picture stuff works as well. We then, rather than calling create account, called edit accounts with those three constants that we've just set up, and again this needs to be a .send call because we'll be updating states. And then we're going to need to fetch those details, which we can then pass to check that they are indeed what we're expecting them to be. So again, we look at the user's mapping with the username hash as the key, we call it, and then check that the values that come back are indeed the description and picture that we updated it with. Finally, we need to be able to actually send a tweet and make sure that all of that works. Otherwise, what would have been the point of all of this? And you can see that, again, with this dtwitter.methods way of casting it, it becomes really, really easy to send any transaction and reason about it clearly. So we're just going to call the tweet method, send that, because again, we're updating states, so it needs to be a .send rather than a .call. And then, rather than looking at dtwitter.methods, here we're looking at dtwitter.events. We're looking for the new tweet event that we specified on our contract earlier. We're filtering it for the specific username hash that we're trying to test against, and we're starting it from block 1. You might think that we should start it from 0, but that throws difficult to debug errors. If it finds something while filtering, then it's going to need to make sure that whatever gets returned as the value for that tweet equals the tweet content that was passed in up there. So now that we've written all of our tests, hopefully it should be as simple as running Embark test in our nice little console here. Embark will recompile the contracts for you to make sure that you get the latest and greatest versions that you've written. As soon as the compilation is done, it should run through the test suite that we've written here. And you can see that we've got 6 tests passing. So that's really great news. It means that we can be fairly certain that our contract is behaving in the way that we expect it to, that when we try to edit stuff or create an account or send a tweet, that it is in fact functioning correctly, which can be really quite calming, especially when you're writing complex contracts. So, I really do recommend, again, and it's so worth stressing this, that writing tests is an incredibly important part of developing smart contracts. The two go together. You cannot write smart contracts without having tests. So now that we've done all of that, we can finally get into actually building the front end for the app. So if you take a look back in our VS Code editor, this is where we're going to go into the app folder and take a poke around all of the free code that you get given in this Embark tutorial. And again, this is the joy of working with open source software and projects in general, is that we all stand on the shoulders of giants. So there's no need necessarily to go through and reinvent the wheel every time you come up with a brilliant idea. You can just use the tools that we're building together as a community to work and collaborate with other people and come to implementations of your idea that would be significantly better and significantly easier to pull off rather than kind of like starting from from scratch yourself. And you'll see that we've set up a whole React app here for you with proper data flows between all of the different components, making sure that both the D2 contract object and the Embark.js library are like globally available through all of the different components, and making sure that this template that you see here is easily reusable for any kind of project, particularly at hackathons where you have 2 or maximum 3 days to produce some kind of working project. You don't want to have to be worrying about learning more about React or various other things when you also need to understand Solidity and smart contracts and all of these new paradigms for writing code. So we strongly recommend use this stuff and build what you need based on what's been written by others, and just take it and improve it. And we're always obviously looking for pull requests, the Embark repo as well, so if you do those, there might be some extra rewards in it for you. If we go back to our instructions, you'll see that the first JavaScript file that we're going to need to edit and make sure that we can wire up our JavaScript to our smart contracts and make them talk to each other and behave as we would expect them to. The first file that we need to edit is this createuser.js file. So there it is. Let's take a look at what's going on here. So we've got a whole bunch of various different React components that we've imported for rendering this specific component down here. We're not really going to touch any of the rendering in these tutorials because that's, like I say, there's no need to do that now. What's really interesting is how do we actually wire this up and get it to speak to the smart contracts that we've written, because that's what we want to learn at an Ethereum hackathon. So the first thing that we're going to do is look at this handle click function, and that's an event that's fired when the create user button is clicked, and it's the thing which handles the creation of the account. So this is the JavaScript that we're going to use to call create account in that Twitter contract object. So now that we've sort of written our tests, some of this stuff should be a little bit more familiar. Here's our handle click function. We're setting our states, and this is loading a variable to true, pulling some stuff from the states, and then the first thing we do is our create account, much like we just wrote in our tests, but here we need to actually specify the methods and then the create accounts function that we're calling. Before we actually call it though, so we don't call .send at that point. In the tests it's fine to call .send because you're just testing it against the local simulator, so you don't have to worry about gas and some of the intricacies of the actual live networks. But here we just set up this create account call, but before we actually call it, one of the nice things to do is to try and get a gas estimate for how much this will cost, this particular function. So you can see that each Solidity makes it possible, rather, in the EVM to have an estimate gas function for any public function in your smart contracts. So when you try and estimate the gas, you have to specify which account it's coming from, and in much the same way as we're using in our tests, again, this is accessible through web3.default accounts. Once we've got the gas estimates, it's always quite nice, in fact, just to send it along with the gas estimate plus a little bit. So what we've done here is set up a little results constant, and it is awaiting this create account send. Again, we need to specify when we send transactions onto the network, and it's not just in tests, we need to specify what account it comes from and the gas that you're willing to send along with that payment. So in this case, you can see we estimated the gas and added a little extra bit in case it's possible that you would send this function to estimate the gas on what you're trying to call. It would return a value to you, and in between you specifying that value in your actual call and sending it to the contract, somebody else calls the contract and changes its state, then it's possible that the gas estimate could be wrong. And again, this is just one of those like paradigmatic weirdnesses of developing on like fundamentally shared architecture. You need to be aware of this kind of stuff, so it's always good to send transactions with a little bit of extra gas in case that kind of edge condition does occur. You can also just uncomment what's going on in this conditional, which is just checking some basic stuff, and will show some error messages if those fail and if you're not using an address, which is just that 0x check there. It's also important to take a look at the handle change function, which comes down here after handle click. So now the username might have been changed, so I'm just going to change that to 20. And what we're going to have a look at here is that, provided that we're not already sort of calling provided that the isLoading variable is not currently going, then we're going to again look at the btwitter methods, look at the userExists function, and make sure that's like all of that is happening, that the user does indeed exist. And then we've written a whole try catch block here for you, which you can uncomment. Let's remove the comments. So once we've called this method to check that the user exists, passing in the hash of the username, if it does exist, then set loading back to false. Put it up that the username is not available. So this is like if you're trying to set your username and somebody else already has it, and if that's the case, then we've got this catch block if this fails, we've got this catch block to show an ordinary error message in this particular component. So that should be everything for create user. We now move into the update user function. So if you take a look here, update user is a little bit further down. It looks very similar to create user, and this is the joy of using reactors. Again, like the modularity that comes with this stuff is just unbelievable, and so it's really easy to create as many different components as you need now using the structure, which is why I say that this is such a useful template, because it doesn't have to be btwitter that you're building. You can just use the data flows and structures that have been set up here and optimized by the Embark team to really kind of kickstart your projects and really get it going with a bang. So again, like most of this stuff is what we just saw in the create user. We also have a handle click function, which we're interested in. So you can see that's the first thing that we're going to do when the click is when that handle click event is fired, is we're going to upload a file to IPFS. So let's take a look here. So you can see this is where we need to put it in. We again just handle some stuff around the states, declare a variable called hash, which we leave as empty. And if the picture passed in when handle click is called is not an empty string, then the first thing that we try is to upload this to IPFS. So this is why the Embark.js object is important. It comes with your .communication or .storage or various different other methods that you can access. And like I said, in one simple line of JavaScript, you can upload a file to IPFS. You can also fetch files. You can also work with Swarm. The possibilities here are kind of endless, and it's incredibly powerful that you can do that in one specific way. So we try and set the hash equal to whatever comes back when we upload that file, and it should return a hash. So the next thing that we need to do is actually try and edit this account. So the first thing here is to get a handle for the edited accounts. So we look at the methods on our btwitter objects. We don't call edit account, but we set it up in much the same way that we did just now for create account and create user, passing in the username hash, the description, and the hash of the photo that we get from up here. In much the same way, We also need to get a gas estimate that we've just discussed. So let's put that in. And then once we've got that gas estimates, we can, in another try-catch block, send the transaction that comes along with that. And you can go ahead and just uncomment again this particular conditional to make sure that it's coming from an address, although it's not particularly relevant to what we're doing right now. Now that we've got both create and update user done, we need to actually write the do tweet components. So if you take a look in here, do tweets, again, it looks very, very similar to the other components. This is the joy of React, is that it's just so reproducible, and once you get the pattern, you've got it for good. So in much the same way, we just need to estimate the gas that it would cost to tweet at that particular time. We can do this in a try catch block again. Once we've got the gas estimates, it's a simple case of sending that tweet. And again, using slightly more than we get back from that estimate because of those edge conditions. And we've got a catch block which will display the error again. Now that we've done that, we need to be able to make sure that we can fetch user tweets and display them to others. So there's a file called usertweets.js. If you take a look here. Similar stuff again. This time we've got a little image avatar in there that we're importing, which is quite neat. And what we're looking for in here is the ability to get user details. So the first thing that we're going to do is remove this line. So rather than sending it equal to an empty string, we're going to call our users mapping, pass in the username hash as the key, and just make sure we get it back. Once we've done that, we have some fancy JavaScript to check the picture. So either what's going on here is like the user object has come back, we're looking at the picture value in it. If it's greater than 0, then we'll look in the Embark.js object, the storage part of it, and we'll get the URL that we earlier stored the hash of that user's picture in. If not, we'll use this image avatar, which is this random little question mark up there that we're currently using at the moment. Finally, in the subscribe to new tweets events, what we need to do is set up the same filter that we set in our tests earlier. So you can take a look here. And all you need to do is replace this line. So let's do that. Let's just format it slightly better. There we go. And once this has come through, if it does filter it, then on receiving data back, it will set the tweets equal to what they need to be, display them in the UI through updating React state. So now that we've got all of that done, we should be able to run this and see if there's any errors. So again, we've got live reloading going on for all of this stuff. So if we just save all of those files, we should see that's being reloaded. Let's take a look in our browser. Start off again at localhost 8000. And Embark will show you these neat little animations while it's building. I probably freaked it out a little bit by saving 4 files at the same time. But at least we get to watch pretty things while it all happens. It will eventually catch up with you if you just give it enough time and speak nicely to your machine. So you can see that if I come down here, choose an account that has some Ether in it, I should now be able to create a user give it a description. Let's see if we can create that user. We've now got our user with the address that's associated with them. So let's maybe choose a file to update to IPFS to upload to IPFS for our user profile. Once we've chosen that, we can click Upload Profile, and this is now stored in IPFS and being displayed on our front end, which is really, really cool. If you open another tab, also localhost 8000, and this time perhaps pick a different account, you see that we can maybe set up another account and see what it looks like from the other side. So I'm quite a fan of Doges. I'm going to upload that to IPFS, because who doesn't love a good Doge? And then perhaps from my first profile, I'll tweet and say, "It's simply the best." And if I come through here and search for other users, perhaps Crypto Wanderer, I should be able to see other profiles of people on my decentralized Twitter clients and the tweets that they've been tweeting about. So let's do another tweets. And it should appear in real time as you go along. And it should also work in reverse, obviously. If I come here and search for this, there we go. Everything working as we expect it to.